Hello.
Hello, hi Rekha, this is Aditi.
Hi, Aditi. In between disturbances. Okay. Okay. Please mute yourself if you're not speaking because there is a lot of disturbance in the line. So if you're not speaking, better put it on mute. Okay, I would be sharing my screen now. So I hope we had done a demo session where we just give a brief introduction into what is this product, where it stands, and all. So we would have a detailed session from today onwards, covering in depth each topic. Okay. On what is IBM Websphere MQ. Okay, and also we would be again starting from the basics. Okay, do let me know if you have any doubts. Interrupt me when you feel that you are unable to follow or you don't understand. Okay, and any questions or any doubts, feel free to ask. Okay, don't hesitate that if I don't know, probably might not be worth asking, but there's no problem. Go ahead, ask whatever doubts you have. Okay. Uh, so today, our first day, we would be covering a basic introduction onto what is middleware, what is specifically IBM MQ series. Okay, where does it stand? How does it operate? A brief history of IBM MQ. Okay, and we would be seeing. I told you in the demo class. It is a message-oriented middleware, right? And we would see what is message and what are its benefits. Okay, if time permits. Okay, otherwise we would continue in the next session. So, firstly, we would see IBM MQ series is a middleware product. Okay, in the TCP/IP architecture. Okay, if you know the TCP/IP architecture, there is different layers where the data has to pass through. Okay, you have the application layer or the front end layer where all the data is given. You then come to have the you have the presentation layer. Then you have your application layer. Then you have your network OS layer. Okay, so middleware is any product that comes in between, okay, your application and your network or operating system. Okay, so if you see this diagram, which is there, you have different applications running, and you have different. They are running on different platforms. Okay, so middleware is a program or a software that comes in between your application and your underlying operating system or your underlying network. Okay, network is if application has to communicate with another application outside network. Are you getting me?
Rekha, can you increase the font size?
Are you not able to see it?
I cannot see the diagram and the information inside the box.
You see it now? You see it
Yeah,
now?
yeah, and now I can see. Thank you.
Okay, so as I told you, middleware is a product that comes in between application and your underlying operating system or network. Okay, so what does middleware products basically do? Okay, what they do is they take up all the application data. Okay, all the business logic. Okay, would be there in your middleware layer. It does the data validation. Is the data proper? It should go. Okay, all these validations are done by your middleware products, and it goes to your, when it goes, it eventually has to reach your database. Okay, where the data is stored. Okay, so IBM MQ series is one of a middleware product. Okay, uh, that facilitates exchange of information across applications. Okay, it's a middleware product that facilitates exchange of messages between application and the underlying operating system. Okay, we will see how this is happening. This is all on a very high level, that we are just defining things. Okay, what is middleware? Okay, shall I continue? Any doubts?
Yeah, sure.
Okay. So next I told you, we talked about middleware. Okay, middleware, you have lot of products available in the market. Okay, like IBM WebSphere Application Server, Oracle's WebLogic Server. Okay, Apache, Tomcat. Okay, all these products are available. Okay, so that's a bigger class which does other functions. We are concentrating on IBM WebSphere MQ. Okay, IBM WebSphere MQ, okay, is a message-oriented middleware. Okay, so what is message-oriented middleware, or MOM? Short form we call it like MOM. What is message-oriented middleware? Okay, what is it? It is a software again that supports sending and receiving of messages between applications. Okay, all the information that are passed to the software is in the form of messages. Messages are its talking currency, you can see. Okay, messages are its basic information. All the information would be exchanged between applications or between organizations in the form of messages. Okay, when I say they are communicating between different applications, it is also necessary to know that this can be done on a multiple OS platform. Suppose MQ software can be installed in different operating systems. Okay, MQ software can be installed in Linux, can be installed in AIX, it can be installed in mainframes, can be can be installed in Windows, any box, you take any OS platform available in the market, MQ can be installed. Okay, and your application, okay, can be written in any code, like any programming language. Java can be written in Java, it can be written in .NET, okay, it can be written in C or C++. Okay, there is no problem. There is all platform independence. Your application can developed or written in any code or deployed in any, and those applications can be deployed in any other server. So it can be a Linux box. Okay, suppose your application is in Linux and your MQ server is in where in Windows. There is no problem of heterogeneous platforms communicating through MQ software. Understand what is MOM? It is software that support sending and receiving of messages between systems for communication. Okay, and when we say the between systems, this can be in heterogeneous platforms or different operating systems. Okay, so MQ being IBM MQ series software being in one platform, your application being deployed in other platform, no problem. There is heterogeneous communication through messages. Through messages, sending and receiving them. It is like, moreover, if you can think MQ system as a postal service, it will be good. I give the example of postal service. Okay, MQ software is like a post office. Okay, where if I send a letter to someone, okay, I will write the address to this person. I post a letter that can be taken as a message for MQ software. If someone gives MQ software a message or a letter, this has to go to the particular destination. Okay, so that destination is expecting that particular message that is destined to go to that. Okay, so MQ software will facilitate that message to reach the destination, like how your letter would be delivered to the person who you have sent the to address. Understand?
Yeah.
Okay. So now we would see. So we saw what is MOM. Okay. Now we would see how does IBM MQ work. Okay. What concepts are used in MQ to facilitate? We told exchange of messages. How does it exchange messages, or how? What is the communication method? In MQ, we use a queuing method. You know queues, right? There's a line in a queue you stand. Okay?
Yes.
So all the messages that come to your MQ software is stored as a queue. Queue is a data structure. Okay, queue is a data structure where you store your messages. And in queues, what is the delivery system? So if you stand first in the queue, you get whatever service is being offered, you get, and you will go first. So it is a first in, first out, or FIFO system in queues. Okay, so application or anything who sends a message to MQ software, okay, that message would come to queue. Okay, that queue will store the message and it will deliver to the destination. Okay, actually there is no requirement of an external storage. Okay, for this product, it is all the storage and all is incorporated within your MQ software. So how does MQ exchange messages? It is using a queuing system. Okay, application writes or program within an application communicates by sending messages to MQ software, and some other application or the same application can receive the message. Okay, that is how MQ software works. We would be seeing how these what all are the components, how it works and all in our practical sessions also. Okay, so we talked about messages. What is messages? Messages is any piece of information that is being received by MQ. Okay, or any piece of information that the application is putting onto MQ software. Okay, and when a message comes, how does MQ process it? It processes or communicates through a queuing system, which is doing first in, first out. Okay.
Rekha,
yeah.
Can you give any example for that?
We would be seeing the practical thing. See, suppose in an example, suppose MQ is mostly used for an external connectivity. Okay, suppose there are two financial organizations. Okay. Example like Citibank and HSBC wants to communicate to each other. Okay. What they would be first doing is they 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 say that okay, we would use MQ software in between us to communicate. Okay.
Okay.
So the setup, how we set up a communication would be later. I can, if I explain now, you will get confused. So I'm not giving the setup. They create their setup, or they create a communication link to MQ software to exchange messages. Okay, so an application which is residing in Citibank wants to send messages to an application in HSBC Bank. Okay, so this is how.
So yeah, it is like a middle part. So
Yes.
from
So
one part to another, like if you book a product, it will directly come to the hub and then it go to the customer. So the hub part is like an MQ, right?
It can be in hub and spoke method. It can be also in client server mode.
Yeah, whatever.
Okay.
Yeah.
Okay. It can act in any way. It does not. It is not specific that okay, it should be in client server mode. Okay. It can also be different types of communication. Only our intention, or the intention of the software, is to facilitate exchange of message. Wherever it is used, it can facilitate the exchange of message. It comes in middle. That's what it comes in middle between your application, between applications itself. Even if the applications are a different organization, it comes in between. Okay, so once it comes, now we are totally concentrated on that particular middleware product MQ series to see how actually it works. Okay, we started with our initial thing of messages and queuing. Okay, if an application sends a message to MQ software, okay, then it would be stored in queues and then later delivered to destination. Okay, it is mostly like a post office kind of thing. A letter that's received by the post office, it stores it, it sees to whom to deliver, it puts it on stamp, and later it delivers to the destination. Okay.
Does the application require more than one queue?
According to different application setup, you can set different queues. If you say one application is sending out messages only to some particular one other application, it will need only one queue. But there can be so many queues. It is not that only one queue, it can be many queues. Suppose I am sending a request. I am sending a, suppose when I say request, suppose you are in your mobile, you are sending a message to see your balance, okay, or your talk time balance. What is your balance in your account? So that is one your request message that you're sending. Okay, you want some information back from the service provider. Okay, like that itself, application will send a message asking for some information from another application. Okay, so in that case, the request message would be sent to one queue. Okay, and the reply, suppose when you reply, your service provider is replying back, okay, this is your balance in your account. Okay, so that is another response to your request message. So that response can be given to another queue. It is not that one application can have only one queue. It can have different number of queues configured. We would be seeing how we can define the queues inside our IBM MQ software. Okay, but we have to just go through some part of theory so that you will better understand. Okay.
Yeah, okay.
Okay, have I answered your question, Aditi?
Yeah, understood. Thank you.
Okay, so now we would just see a brief, a history about IBM MQ series. not very very needed, but it actually started. Sorry, just a second. Sorry. Sorry for that. Okay, now we would see a brief history. Okay, initially MQ series came only with the mainframe system. Okay, it was around in the 1990s that it came with. It was only deployed initially on the mainframes. Okay, later over the developments, okay, MQ series software was progressively adapted into all the operating systems. Okay, today there are more than 35 operating platforms that actually your MQ software can be installed. Okay, but on a real-time market, okay, the real IT industry, mainly it is on Linux, AIX, Windows, AS400 and mainframes. Yeah. And also Solaris. Okay, these are the most majorly or widely used. AS400 mainframes are a different category altogether, because those are a different kind of operating system. Okay, I'm not sure if you are aware of it, AS400 and mainframe, but we would be seeing in our classes, we would be seeing the widely used Linux, AIX and Windows. Okay. Now we would go with okay, how is we told application send messages and MQ software will store the messages in queues and deliver to the destination. Okay. Now there is something called synchronous and asynchronous communication. Okay. So what is synchronous and asynchronous communication? So suppose take this example. Okay, I am an application, or there is how we can give an example is HSB Citibank is communicating with HSBC through MQ software. Okay, Citibank's program or application is sending a message across MQ software to HSBC. Okay, so at that time, okay, an application in Citi is unaware if application in HSBC is available or it is up and running. Okay, you don't have any information, right? Because it's totally outside your network, you don't have any visibility into that. Okay, but still you are sending a message to that particular application. Okay. Then the application will just send a message and it will forget about that message. Okay, okay, there is a message there, but the application is not bothered if the destination to which the message should go is actually available at that point of time. Okay, what can happen is the message is sent to MQ software. The MQ software can see, okay, is this destination available, or to where it should go is available, or the program is available to take messages from MQ software. Okay, if it is not there, the message will still remain in the queue. Once the message application comes up, it will pick the message from that. Okay, this form of communication is called as an asynchronous way of communication. Asynchronous communication, because applications are independent of their availability. Okay, I can send a message, or an application can send a message. It can be picked up when the other application or the destination application to which it should go is down, and it can come up later and pick up the message. Okay, but the sending application is not bothered if the application or that program that it is sending message is readily available at that time. Okay, this form of communication is called as an asynchronous way of communication. At this point of time, such software like our IBM MQ series comes into picture, where we use asynchronous mode of communication. The message is still there in our MQ software in queues. Okay, it will be there till the application which is currently unavailable or down for some reason comes up and picks up the message. Okay, this is called as asynchronous communication. Okay, now what is synchronous communication? Synchronous communication means the programs which are communicating with each other should be up and running same time. Suppose there are two applications, application A and application B. They are communicating each other. When application A sends a request to application B, the application B should be up and running at the same time so that the requested service can be provided. Okay, so that is a synchronous way of communication. There's an application sending a request. The response should also come in the same time. Till that time, what it does is it will wait for that particular response to come back. No other further processing will take place in that application. Until it comes back, the application will not process anything. Okay, so application should be readily available when the service is being requested. Okay, that is a synchronous way of communication. Okay, understood. We in IBM MQ series follow asynchronous way of communication. Application is not bothered if the other side to which it is sending message is available to receive the message, but the software gives you an assurance. The middle MQ software gives an assurance that the message would be finally given to your destination. Understand about that?
Nareka, I didn't understand that.
See, I'll tell you. You are sending a courier message. Okay, someone has sent a courier to you. Okay, it is received by the courier service. That is, consider the person sending you courier as your sending application. Okay, courier service is your MQ software. Okay.
Okay.
Now the courier comes to the courier service. It says okay, this is to. It will say okay. Suppose it is sent from Delhi to Bangalore. Okay, so the person goes to a courier office, gives this courier. From Delhi, from that office it will go to the Delhi head office. From there, it would come to the Bangalore head office, and it will go to the actual Bangalore sub office. Okay, so that is how that is an MQ software in between. Okay, it comes to your courier wherever it should go. Okay, it is there in Bangalore courier service now. Okay, now a person comes and tries to deliver it to you. Okay, so the sender of the courier is not sure if you are there in town. He does not know if you are not there in town. Are you available to take up the courier? But still, he sends the courier. Why? He knows if you are not available, also the courier service will keep it for some time and check. And if still not available, the courier will be sent back. Okay. So he is assured that the courier will not be lost. Okay. So when the courier person comes to deliver, suppose you are not there for first time, you are not there in your home. Okay, it goes back. So this is what asynchronous communication happens. You are the application, you consider courier service in application scenario, and the application is sending message to MQ software. The receiving application is currently not available. It is in asynchronous mode of communication. Applications are not available simultaneously. There is no need of application being available simultaneously to send and receive message. The sender, or once you send the courier, it is sent. You cannot say now give back because the application is unavailable. It is sent, but it will be delivered when the person or the application becomes available. Understand asynchronous communication?
Yeah, a little bit confusion in both synchronous and asynchronous.
Synchronous way is, suppose how can I say synchronous in a real-time example is how I can say that. You are going to a bank. Okay, you are going to a bank and you are going to deposit some amount to bank. Okay. So you go to a bank, you fill up a form saying this account this much money, and you give that slip to a bank teller. Okay, so the teller has to be available then and there. So your information is okay. Deposit this much amount in my this so and so account. Okay, the bank teller has to be readily available there to process that message, right? Okay, your information is this. This needs to be processed. So the banking service, whoever provides the banking service, needs to be present at that time to take up your request. If the person is not available, you cannot keep that form there and leave, right? Because no one will take up that request. But in a courier service, it is not like that. You can just send the courier, leave it there. It will be whatever is it, to whoever it should go, it will reach. Okay. But see, synchronous communication, to whoever you are sending or giving a message should be readily available to give you that service. Okay, so the same thing. If there are two applications communicating to each other, they must be always, suppose application A sends a message. That message should be read by that receiving application, and either it will say, okay, I have read the message. You send a message back saying that, okay, I have acknowledged this message, or I have received this message, or it will send a response back taking appropriate action on that message and send up, okay, so and so whatever is requested is done. Okay, so when you go to a bank and the bank teller says, okay, this request is done, you get an assurance that, okay, this is done. They give you a chit saying that, okay, it's stamped by that person, saying that, okay, now in your account that money will get credited. You are assured that this would be there. They give you an acknowledgement also, saying that this is done. That is how synchronous and asynchronous communication happens. Clear?
Yeah.
Now we saw in MQ software what is the communication method that we follow. That is the asynchronous communication. Okay, the sending application. When I say sending application, any application that puts a message to MQ software. Okay, sends a message and is assured that, okay, it forgets about the message and it knows the message would be delivered to the destination, even if that destination is not available at that time. Okay. Now we would see what are the advanced. Sorry.
This mom also, it will same, right? It will send the message and it will waiting for the reply. So what is the difference between these mom and synchronous?
Mom is not sending messages and waiting for it. Mom is not anything, but it facilitates the message exchange. It will send message, it will receive message. Okay, messages are, it is a message oriented middleware. That means messages are its talking point. It will get a message. Okay, and it will deliver the message. So messages are it's what I say, it's important factor. A message will come, then it will do some validation at its end, and it will send it to the destination. Okay, if an application has to get a message, application will connect to your MQ software and receive the message. So message is the important characteristic or the important currency in that software. It does not say that mom is like, it will send message and wait. No, it is just that your message oriented middleware product, its talking thing or the main thing for it is a message. Okay, how the asynchronous and synchronous mode of are the different modes of communication available between applications. Okay, you can design applications. Okay, this is at the application level. Okay, you can design applications to be of a synchronous mode. See, without middleware product also application can communicate with each other. Okay, then the program has to be readily available. Okay, if a program A is calling a program B for some service, okay, for some service, and suppose if the program B is unavailable, will it work? Will program A be able to communicate with program B if it is down? No, right? Such a communication method is synchronous communication. It is modes of communication. Message oriented middleware is that is a product that for it the basic input or basic exchange is through messages. It has ability to receive messages and it has ability to send messages. Understood? Don't confuse MOM with modes of communication. Modes of communication is not only based for middleware products. It's common. Okay, that's a very broadened way of communication between applications also. Okay.
Okay.
So we would see Aditi, you are clear, right?
Yeah, I'm fine.
Okay. So next one we would see what are the advantages of WebSphere MQ. I told you WebSphere MQ evolved around 1990s. Okay, and now it's around 2016, but it is very much prevalent in the market. There are many big organizations still using this product. We would see what are the advantages that makes this a very hot selling product in the market. Okay, even if there are many products which have come, but still this product is still used. Okay, the first thing is called as assured delivery. It gives you assured delivery. So when I was telling about the courier service, okay, courier service is an assured delivery. You are assured that once you send anything to a courier service, it will be either delivered to the destination. If the destination is not available to pick it up, they can send it. We will put our address and phone number, and they'll call you and tell you that okay, this person is not available. If you want, you can. We are sending it back. You can collect it from our office. Okay. So this is like the same MQ software also gives you this assured delivery. So in asynchronous mode of communication, I told you, application sends a message and just forgets about that message. Okay, but MQ software gives you assurance that okay, see, you have sent a message to me, I will deliver. I take up the responsibility of delivering this message to your destination. Okay, so assured delivery is an important feature. You understood what is assured delivery?
Yes.
Okay, it gives you an assurance that it will be delivered. Okay, it is also called as a time independent processing. It is not dependent on time. At same time or at concurrent time, it should be available. Hold on a sec, please. Sorry for that. Okay. Uh, so one is the most biggest advantage of WebSphere IBM MQ is that assured delivery or time independent processing, because it is not time dependent. Okay, the time the message is sent, it must be processed. No, it is not time dependent. Okay, but it is assured that a message or an information received to your MQ software will be processed by the destination. Okay, understood?
Yeah. Carry on, Rick.
Next one is your asynchronous messaging support. It supports both asynchronous and synchronous modes of communication. Okay, you can design your application in such a way that it actually uses asynchronous or synchronous, but mostly in MQ you would be using asynchronous mode of communication. Okay, you can also use MQ software to have a point-to-point communication. What is point-to-point? Suppose Citibank is communicating with HSBC. Okay, that is like Citi to HSBC only. That is a point-to-point communication. Okay, one sender, one receiver. Okay, one sender application, one receiving application. That is a point-to-point communication. Okay. It can also use publish subscribe, but I'm not explaining publish subscribe because we'll have a publish subscribe session later. Okay, I'm not sure if you know publish subscribe. It is publish subscribe is like, suppose you get in your phone, probably you might be getting offers, right? Suppose you use Airtel as a network provider. Airtel can actually give you many offers, so you will get messages. Okay, those kind of messages. Okay, how it is done? That is, a person somewhere, the network provider is publishing that message to all the subscribers of that particular network. Okay, that is like a publish subscribe, but we will have that session in detail later. Okay. Next one, it is a loosely coupled architecture. I have written it is loosely coupled architecture. Okay, what is loosely coupled architecture? Applications, I told you, applications can be developed in multiple programming languages, right? Suppose I am developing a Java application, and another application is being developed by another developer in .NET. Okay, suppose these two programs has to use IBM MQ software, okay, as a message-oriented middleware. Okay, so in that case, suppose there's a restriction that .NET application cannot communicate with MQ. It becomes an overhead on the developer that he wants to use .NET features in that application to be developed because maybe it is more easy or it's more user friendly. That developer wants to develop using .NET, but since your requirement is to integrate it with IBM MQ and MQ has a restriction that the .NET application cannot communicate, and it becomes an overhead, right, to see the compatibility of your software. But in MQ series there is nothing. Application can be developed in any programming language, deployed in any operating system. It can communicate with MQ. That's another big advantage, that the MQ product is very much prevalent in the market, that it is a loosely coupled architecture. Okay. Next one is application can communicate independent of platform. Platform independence is there because it is there in application can be developed in different programming language. It can be deployed in different operating systems as well. Heterogeneous platforms can communicate with MQ software. Okay, and another way is it gives you a more security. How message security is very much prevalent in MQ, because MQ series, when I say Citibank is communicating with HSBC, okay, the network actually is through the local, the internet is there, or it goes out through internet, okay, the WAN, the wide area network, okay. So when it goes through a network outside, it has to be very secure, okay, because financial institutions and all can actually transfer messages of like some payment messages, okay. If it is getting tampered or hacked in between, it is a loss for the organization. So it gives you security through SSL. SSL is secure socket layer, but we would see SSL how it is done in other sessions, but it gives you security, okay, for the messages that are traveling across the network, okay. So these are the different advantages: assured delivery, loosely coupled architecture, platform independence, message security, asynchronous and synchronous way of communication, it gives you both point to point and publish subscribe messaging model, okay. These are different messaging models. Point to point is like I can communicate only with one person, but public subscribe is the message which I am sending can be delivered to number of people, okay. So these are the advantages. There is one more point of persistent and non-persistent messages, okay, that I will take in the next slide. So that's why I have not mentioned that, okay. We will see what is persistent and non-persistent messages, okay. That comes part of a topic called as message retention types, okay. What is message retention, okay. So see, I told you MQ is assured delivery. Your MQ software is assured delivery. Any message coming to that software must be there, okay. It gives an assurance that the message will go to destination, okay. What if the software crashes, okay? What if the software crashes and comes up later? At some point of time it comes up. What about the message? As per assured delivery, we say that all the message that reaches this software should be there, okay. So when it comes up, all the message should be there. So how do we do that, okay? How do we do that kind of an activity? That is using message retention types, okay. There are two types basically: non-persistent and persistent. Very, very important topic, okay. What is message retention, okay? So first is a persistent message. What is persistent message? Persistent messages are messages at no point of time we can afford this message to be lost, okay. That kind of message, any application says that I cannot afford this message to be lost at any point of time, okay. This is a very important message to me, okay. I cannot lose this message, okay. That kind of message which should not be lost at any point of time, okay, that are categorized as persistent message, okay. Now we will see how you make persistent messages to be stored. Suppose, okay, there's a application says it's very important to it, okay. It says that, okay, then we say, okay, that is a persistent message, okay. It comes to IBM MQ software, and the software crashes, okay. How do we make sure that, okay, that is a persistent message? How do we make sure that when the system comes up, that persistent message is still there in our queue? How do we do that? Persistent messages, when it comes to our system, okay, it is written to our disk, or it is stored in our storage, external storage. You will have MQ software will be deployed on a server, right? A server, or it would be running on a Windows, Linux, or AIX box, and that server will have a storage. It will have a file system, right, where all your data is stored. So those persistent messages will be written to your disk, okay, so that in case of any failure to the system, when the system comes up, it will reach the file system, Okay, and say, okay, this message is there in this queue. Okay, this is a persistent message. This is there in this queue. This and that message will be processed to that queue again. Okay, understand? Persistent messages are messages which are written to the disk and must be able to so that can be recovered in case of a failure in the system. Understand what is persistent message? Okay, and now we will see who all can mark these. So when an application sends a message, it can mark the message type to be of persistence type. Okay, that can be done along with the application. When the application is being coded or when the application is sent, message, it can say it is persistent message. Okay, it can also be done at the IBM MQ level. We would see that when we see our practical section. Okay. Next one is non-persistent message. What is non-persistent message? If persistent messages are to be written to disk, non-persistent messages are not. They say that these are not that very important message. If I can afford to lose these messages, suppose it is like stock exchange. Some you are doing a trade. Okay, you want the stock price of something. Some particular, suppose Infosys share, you want to know the stock price. Okay, the stock price, the message, the stock price of Infosys at particular time. It is not that important to you, right? Because stock prices keep changing every time. So that by the time you receive the stock price for Infosys, the actual Infosys stock share would have changed. Okay, those kind of messages which you can afford. Those are not that very important messages. You can afford to lose it. Those are non-persistent messages. Non-persistent messages are not written to the disk. So in case there is a failure of the software, those messages would be lost. But since they are already categorized that, okay, if the messages are lost, I don't have a problem. Those kind of messages are called non-persistent messages. Understand persistent, non-persistent, Aditi and Shyam?
Yeah, sure. I understand that.
Okay. So when you see persistent, non-persistent, there's another overhead. Okay, persistent message processing becomes a bit slow compared to non-persistent message processing. Why? Because persistent messages has an overhead of written to be written to disk. Okay, non-persistent message has been sent. There is no overhead that okay, it has to be stored. It has to be stored in the disk. It can be just transferred. So when an application architecture designs, they would choose whether they want to use persistent or non-persistent message. In MQ, both message types, most retention types, persistent and non-persistent messaging is supported by MQ. Okay. Any doubts? Okay. I would stop for today. Okay. I would stop for today so that you can just take up all this. Okay. Just try to remember what I've told. What is MQ, message over middleware? What is middleware? What is MOM? How MQ uses it using messages and queues. Okay, we talked about the different modes of communication. What is the different types of message retentions available, and the advantages of IBM MQ. Okay, I would stop here so that I don't overload you. I don't want to first day itself bombard you with information. Slowly take it up. Any doubts? Let me know. I will clear it off in the next session. Okay.
Yeah, Arika, if you don't mind, a small suggestion.
Yeah.
Whenever you're saying about anything like synchronous, could you please tell me about this with example? So we're not that much aware of these things. So if you don't mind, tell me with the examples, we'll easily understand it.
See, real time. What do you mean by examples? that I want. Like suppose I can give you scenarios, like as I told you, but real-time examples, like I cannot, because I don't have an application at my end to actually show you that. Okay,
No,
that would be.
no, I'm not asking. Yeah.
So what is your expectation when you say an example?
So actually, what I'm saying
No,
is, if you're
I
really
know you
saying,
are not. Go ahead.
hello,
Yeah, go ahead.
sorry.
Go ahead. Go ahead. You were telling
Yeah,
something, right?
yeah. You were saying like with the postal example, like postal example and HSBC example, like these kind of examples you were saying, we'll easily understand it. So that's what I'm saying.
Oh, okay, fine. No problem. I just wanted to know what examples you were expecting. Okay, see,
Yeah.
this is just theory. Okay, this we would be doing more practical session, but I have to explain all this theory before you actually go to the real practical scenarios. Because in real practical scenarios, I will not be mentioning these in detail. I will just say persistent message or a non-persistent message, or
Yeah.
then you have to know what is it. That's why I am taking some time to actually explain you theoretically. If you don't understand, tell me. I am ready to explain you how many times. I don't have a problem.
Yes, yes.
Tell me if you don't understand.
Actually,
Okay.
what I am saying, Rekha, because you are software people, you people easily understand what is deployment, these kind of things. We are not aware of these deployments, and we don't even know what is deployment. So that's what I'm saying. This.
Okay. See, Shyam, if you don't understand, tell that, no, I didn't understand. Can you explain again? Or you need an
Yes.
example. You tell that. Okay. So you
Yeah.
don't hesitate to say that you didn't understand. You don't understand. Tell openly that you didn't understand. I've not got what you understand. I'll explain
Sure.
it again. Okay, no
Sure.
problem.
Sure.
And same
Sure.
for you, Aditi. If you don't understand, I know you are also not from the IT background, but if you don't understand the particular term which I say, feel free to ask me again. Okay.
Sure.
Okay. Then we are done for today. Okay. We would revise these topics, and also this is only basics that we have done. Okay. This is only basics. Okay.
Okay.
This is not even basics of MQ. This is common. Message retention and all is common across middleware itself. So we are just going very basic. Okay. So tomorrow also we'll revise this. Go through. You can just Google it. Suppose message retention, you can just Google it. Or IBM MQ basics, you can just Google. You will get a lot of information from IBM in the internet itself. You can go through the topics which I have covered. You can read through if you have time and
Yeah.
compare what I've told and see if there's any doubts. Okay, I don't understand this. You can ask me. Okay, within 1 hour I cannot give you all the details. Sometimes I can give you the basic, the most important details. Okay, further you can read through internet. I will also be providing you a document, training document. Okay, you can read through that also when each topic is being covered. Okay, if you both can give me your mail IDs, or you pass it to you give me your mail IDs, I can send you the training document also. Okay. Okay. Then we are done for today. We'll continue tomorrow. Okay.
Okay. Sure.
Okay. Okay. Fine. Any problems with my teaching style? Feel free to tell me that. Okay, no, I'm not able to understand. Okay. Don't hesitate.
Rekha, will you discuss interview questions? Is there any session, or do we have to ask during the class?
Interview questions is not actually there in my thing, but I can, if you want a particular session, Yes, then just have a talk with the training institute if you want to have if you want to have an interview question session, because that can happen only after the end of all our sessions. It cannot happen in between, right? So it can only happen after we complete the entire topics and then go to interview questions. If you want to have a separate session, both of you can just reach out to the training institute to say that the requirement is this, then probably they'll discuss and come back on that requirement. Okay, I can do that, but just check with the training institute.
Yeah.
Okay. Okay then. Okay then. See you all tomorrow the same time.
Thank you. See you.
Yeah. Bye bye.
Thank you, Rika.
Bye.